In section 5 of chapter 8, you'll be using the properties of trapezoids and kites. So by the end of this, I expect that you'll be able to do some algebraic manipulations, set up equations, and solve for unknown variables using the different properties. One word of advice, get ready to draw pictures. You're going to want to draw everything out because visually seeing these is really going to help you out. First picture I've drawn here is a trapezoid, and it's still quadrilateral. It has 4 sides, but it has exactly one pair of parallel sides. So here I have the 2 parallel sides indicated, and those are called the bases of the trapezoid. The other sides are called the legs. A kite, well, this one you may have seen before. I'm sure you've all flown a kite before. But your typical kite, it might not look like the ones you've flown that are dragons or whatever else, but your typical kite looks like this. And what we have going on with the kite is the adjacent or next 2 sides are congruent. Opposite sides are not congruent. At this point, you're probably thinking, seriously, Mr. Q, more theorems, you've got to be kidding me. But I do promise you, these theorems are not too involved. They kind of make a lot of sense, and lucky thing about them is there's no name to them, so you don't have to memorize what they're called. You just have to realize what they do. If a trapezoid, so here we have a trapezoid, is isosceles. Now what I mean by isosceles is that the legs are congruent. Then each pair of base angles is congruent. So angle A and angle D are congruent, and angle B and angle C are congruent. Big error that's often made here is this is a base AD, but also BC is a base, because remember, it's any of those parallel sides. Those are considered bases. So the angles adjacent to that base must be congruent. Kind of going the other way around, if the trapezoid has 2 congruent base angles, so angle A and angle D are congruent, or you could say B and C are congruent, then you could say that this trapezoid is isosceles, meaning it has 2 congruent legs. This last theorem did get cut off a bit, but I'll explain it on the picture above, and it is on the next page. A trapezoid is isosceles if and only if its diagonals are congruent. So you take a diagonal, AC, and you take a diagonal, BD. If those are congruent, then we have an isosceles trapezoid. In chapter 5, we looked at the mid-segment of a triangle. And basically what we did was we took the midpoints of 2 sides and connected them. That's exactly what we're going to do again. Except now we're going to extend it to a trapezoid. You'd have to take the 2 legs of the trapezoid, not the bases, so the sides that are not parallel. So we take AD, chop it in half, mark that point M, chop BC in half, mark it N, and connect those points. What we end up with is the mid-segment, and it happens to be parallel to the bases of the trapezoid. An interesting thing that occurs here is a relationship between the length of MN of that mid-segment and the 2 bases. And the relationship is stated here. MN is equal to half of the sum of AB and DC. Another way to see this is MN is equal to, add up the 2 bases, AB plus DC or CD, and divide by 2. Now we can manipulate this any way we like. We could also write that 2 times the mid-segment, 2 times MN, is equal to the sum of the bases, AB plus DC. You're going to have to be able to manipulate these things and solve using plugging in different values. So if I told you the value for AB and I told you the value for DC, you'd be able to plug it in and solve for MN, or vice versa. Last couple theorems for this section are dealing with the kite. If a quadrilateral is a kite, so here we have a picture of a kite, then its diagonals DB and CA are perpendicular. So all kites, and you may have seen this before. I mean, when you see kites in maybe a story you're reading or when you're studying Ben Franklin, you often have this crossbar and then your typical kite representation. You've known that these crossbars are perpendicular, at least you've seen them that way. So basically, I mean, just know that the diagonals of a kite have to be perpendicular. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent, and only one. Because if you look at this kite, clearly D and B do not look congruent. But if we look at angle C and angle A, which are between congruent sides, the angles itself are actually congruent. So if you have a quadrilateral that is a kite, and you have congruent sides, then you have the opposite angles are congruent, but only one of the pairs of opposite angles. Let's apply what we've learned about trapezoids and kites. We'll first start with the trapezoid. So here we have an arch in this diagram, and we're given one of the angle measures. We need to find the other three. The first thing, the easiest thing for me to find is angle K, because the measure of angle K is going to equal the measure of angle L, since in an isosceles trapezoid the base angles are congruent. So we could say that this is equal to 85 degrees, and I can write it in on my picture, 85 degrees. Now that I know that, what I recognize is we have two parallel lines and a transversal. So way back, we have to think to like chapter 3, was it, perhaps? We have a transversal, and these are consecutive interior angles. What we know about consecutive interior angles is that they add up to 180 degrees. So the measure of angle K plus the measure of angle J is going to equal 180 degrees. Therefore, plugging in what I have for the measure of angle K, 85 plus the measure of angle J is equal to 180 degrees. Subtract 85 from both sides, and we get that the measure of angle J is equal to 95 degrees. Again, I can write that in on my picture, 95 degrees. The measure of angle M is then also 95 degrees. Why? Because we have that the base angles of a trapezoid are congruent. So J is congruent to angle M. And I can write that in my picture, 95 degrees. And I'm done. Here's the formal write-up. It's up to you if you want to pause the video at this point and jot it down. I'm going to move on to the next step. Alright, problem applying the mid-segment of a trapezoid. So we are asked to find MN. And we're given some values for PQ and SR. So what I'm going to do is actually use the formula in this case. MN is equal to the sum of the base sides of the trapezoids divided by 2. So I can add up PQ and SR divided by 2. That should be my mid-segment MN. From here, I can just plug and chug. So I have that PQ is 12 and SR is 28. Plug those in. Adding up in the numerator first, I get that MN is equal to 12 plus 28 is 40 divided by 2. MN is therefore equal to 20. You might start to notice a pattern. The difference between the mid-segment to this base here is 8, and the difference here is plus 8. So that should be a pattern that shows up, and you can kind of check yourself with that. The last example deals with a kite, and we're asked to find the measure of angle D. What I can notice right off the bat is that the measure of angle D must be the same as the measure of angle F. And we also know that the sum of all of the interior angles of any quadrilateral is 360 degrees. So I have that the measure of angle D plus 124 degrees plus measure of angle F plus 80 degrees is equal to 360 degrees. I've basically gone around and added up all of the interior angles of this kite. From here, I'm going to solve this algebraically. First thing I can do is put my like terms together. So we have that the measure of angle D plus the measure of angle F plus 124 plus 80 is 204 is equal to 360. Now I'm going to subtract 204 from both sides. So 156 is what I get is equal to the measure of angle D plus the measure of angle F. Well, we already said that the measure of angle F was equal to the measure of angle D, so this is just 2 times the measure of angle D. I'm just taking the measure twice since they should be the same, is equal to 156. So my last step, divide by 2, and we get that the measure of angle D is equal to 78 degrees. Here's the formal write-up. This is going to be the end of the lesson. You can pause it here and then write this down if you'd like. But I'll just leave you with this fun little picture. And believe it or not, these are not moving, even though this is a video. This is just a stale picture, and it's created an optical illusion. I thought it was pretty cool.